And he was quite a pioneer in that work. He was really just a filmmaker, but he wanted to have this greater experience. Now, Ivan Sutherland the same way. He'd been staring at computer screens for years, and he said, you know, I want to get into the screen. I want to break the glass. Is there any way that I can do that? And he started working on what we now call today the ultimate interface, or what we also call virtual reality, where he was using this computer graphics capability with a head-mounted display to show things in 3D. They're really simple because of the computational capabilities we had at the time. And so these two guys were pretty much working on the push. They saw this thing that they could probably do, and they wanted to do it. Now, in my case, it was something else. We're in the middle of a war, and I was going to be drafted, so I decided to go in the Air Force. That's probably the best way to go to war, in the Air Force. And so my job was, how in the world do we interface humans with machines? And so basically, this was the kind of machine that I was working on, where you had one pilot interfacing with that. And there were a lot of problems. In the case of the F-15 cockpit, there were lots of switches, lots of displays. And we did evolve that using new technology from what you see here in 1972 to 1988, when we went to more electronic displays, and we thought we were making progress, but it turns out we weren't really. We were actually making it more complex, more difficult for the pilot to form a mission. So we had this reality of this human connected to this machine in a very dynamic environment, where things were happening all around, and these crew members were trying to deliver energy from one place to another. And with these particular workstations, it was very difficult to get bandwidth to and from the brain in order to accomplish that. So there are really four problems, among others, that I started looking at. That was my job, figure out how to solve these problems. One is that we were aiming the airplane in order to aim all the systems on the airplane. We also had this problem of seeing at night. We had these marvelous sensors that would let us look into the nighttime. But our cockpits were so jammed with instruments, we didn't have enough space to put in a display so we could even see what's coming from the sensors. We had also this problem of complexity. Here we had an aircraft that had 50 computers on board and one operator. And how in the world were we going to make sense of that? And how is this one human going to operate all those computers? And then there was this whole deal that you had the outside in and inside out. There was a world out there that you needed to tend to, but all the instruments in the cockpit. So you had to move in and out in order to make sense of things. So those were the problems I was trying to solve. So early on, I decided, you know, we got to do a paradigm shift. We got to do this differently. So I started working on, not long after I arrived at Wright-Patterson Air Force Base, on different ways of representing information. This whole business of small displays, well, I discovered, you know, why don't we just take something as small and make it appear to be big and project it as a virtual image? So you see here is sort of the world's first helmet-mounted display that does a virtual image projection. And here's Lieutenant Furness wearing that very first helmet-mounted display. Then there was the aiming problem. Here we were aiming the airplane in order to aim all the systems on the airplane. Well, I said, well, can't the pilot really see the target out there? Isn't that good enough? So we started working on a way to take the helmet position of that crew member and use it to aim the systems on the aircraft. And here you see the world's first helmet-mounted sight in 1969 with Lieutenant Furness wearing that. And of course, the whole idea is to put these into real airplanes and test them, which we did. And we found that, you know, one of the cool things is, what if we put the two together? What if we put the helmet sight and helmet display together? Now what we'd have is this virtual image that we can move around wherever we want to, but we always know where it is by using the tracking system. So you see in 1971, this virtual, what we call a visually coupled system. So this let us move those sensors outside the aircraft wherever we're moving our head, but at the same time getting the visual scene. So it was just like a picture window we cut in the cockpit, this huge picture that we could move around and basically get rid of the obstructions of the cockpit. This was remarkable, transformational. Now, there was this problem also, complexity. Here we have this aircraft, in case of an F-16 aircraft, Falcon, there are about 50 computers on board. You have a computer for digital fly-by-wire, for aid data, for stability augmentation, for your electronic intelligence stuff. And the problem is if this airplane is just sort of inherently unstable. If you lose the power in the main bus of your aircraft, it just isn't going to be a good day. And you have to leave the office really fast because it just isn't going to work out for you. So I had to go to work on how in the world do we solve this bandwidth between the human and the machine. And that's when we came up with this idea of a super cockpit, a cockpit that you wear. That basically provides a circumambulance of three-dimensional information to the human. But we had to sort of test this idea, and how would that work? And this is where we really got deep into virtuality. It turns out that virtual worlds are there along with the real world. And they're reflections. They're things that appear in space that aren't really there, but we can interact with them as if they are there. And so harnessing this idea, making accessible this notion of virtuality was what propelled us into this super cockpit. But we had to build a simulator. Now, some of you may have seen this photograph before. This is my so-called Darth Vader helmet. I started building this in the late 70s, and we turned it on for the first time in 1981. It was amazing. 120-degree field of view, binocular, a 16-bit tracking system, speech input, eye tracking, all these kinds of things that we were working on in this time. And so we were able to explore how in the world do we organize and put this virtual cockpit, this virtual information together and take advantage of it. But one of the things we discovered in the process of using this device is, oh my goodness, what have we created? Because we found now it was like in an IMAX theater where you could look around. And we found that instead of looking at a screen that was a head-mounted screen, it was like we were pulled inside into another world. This transformation was remarkable. And when we did that, those three-dimensional abilities that we would use in the real world, we could actually now use in this computer-generated world, which meant that we had much more power and much more bandwidth to and from the brain and our psychomotor capabilities. So the Darth Vader helmet propelled us into the super cockpit. And the super cockpit was basically taking all of these things and using new devices, new technologies. At the time, we were using miniature cathode ray tubes. You had 15 kilovolts sitting on the side of your helmet, projecting all these electrons on the screens and things like that. But it was amazing what we were getting into holographic optics and things like that. So here's an artist's rendering of this so-called super cockpit. And the whole idea is to transform what you'd see in a normal cockpit with 300 switches and 75 displays, and 11 switches on the control stick and 9 switches on the throttle. And you're flying twice the speed of sound, pulling G's to the boundaries of consciousness, and being shot at the same time. That's sort of a busy workplace. And one guy told me, he said, gosh, that sounds like a standard day in New York City to me. But nevertheless, this is the problem we were trying to solve. So here we see a traditional, this is an F-18 cockpit actually, and all these displays, all this information. You push one button, the whole display changes to another set of symbols. So you have a vertical situation display, a horizontal situation display, a radar display, a storage management display. You have all your navigation systems and things like that. It's just overwhelming. Pilots complained that their brains would ooze out of their fingertips because they couldn't remember what mode they were in. And those switches on the control stick, they change what they do depending upon what mode you're in. So that was the problem. So what we were able to do then is take this information that was all discrete and separated and highly coded and basically build a fused display, a mimetic display. It's something that would give the power to gestalt, to get an understanding of everything that was going on in the world at the same time. The fusion of your data information, of your threat information, of your navigation, all these kind of things were projected in one-to-one registration with the real world. If you're flying at night, you'd see this picture. If you're flying in the daylight, you would actually see the outside world with some of this information superimposed on top of it. So it was a fusion between VR and AR that would allow us to do this. And this was, of course, the concept that we were trying to work on. So this paradigm shift also let us deal with this outside in and inside out problem. Here we have, we need to have a sort of an overview of what's going on in the world. Even though we're in this instantaneous part of the world, this location of